the last word problem question we have, again, we want to identify whether or not it's a simple increase, simple decrease, doubling time, or half-life problem. So if we read through, it says the half-life of caffeine, okay, is in a healthy adult is 5.7 hours. The average cup of coffee has 200 milligrams of caffeine. So we got to write an equation for this model in part A. Well, we know this is a half-life question, so that means that half-life is your mass is equal to your original mass times 0.5 to the exponent actual amount of time gone by over whatever your half-life happens to be. It tells us that the half-life is 5.7 hours. So our H value is 5.7 hours. So we already know that the H value is going to be 5.7. And it also tells us that an average cup of coffee has 200 milligrams of caffeine. So 200 milligrams, that's actually our MO value, our original value of caffeine. So in this case, 200 grams. So if we want to write an equation to model this, we could say that the mass of caffeine, or the amount of caffeine, is equal to 200 times 0.5 times T, or M is equal to 200 times 0.5 to the exponent T divided by 5.7. Okay. So we're going to use this calculation then to determine the amount of caffeine in your body after 12 hours and after 24 hours. So I'm going to take my equation, 200 times 0.5. It says after 12 hours. Again, 12 hours is the same time amount. So let's put this as 12 over 5, 12 over 5.7. Okay, that's an exponent. So we'll just quickly put the exponent sign in there. So the mass is equal to 200 times 0.5 to the exponent c 12 divided by 5.7 is going to equal approximately 2.105. Okay, so 2.105. So if I complete the equation, I end up with 200 times 0.5 to the exponent 2.105. Okay, and that's going to equal approximately 46.5 milligrams are going to be left in your body. Okay. After 24 hours, we could do it for 24 hours, but I actually want to change this. Instead of doing it for 24 hours, let's say that we wanted to know how much caffeine was in your body 90 minutes. Okay, so 90 minutes after you have your cup of coffee. So again, we know that we have to convert that 90 minutes into hours. So 90 minutes in terms of hours is 1.5. So because our doubling time, sorry, because our half-life is given to us in hours, we have to turn the amount of actual time into hours as well. So same original equation, m is equal to 200 times 0.5. In this case, the actual amount of time, the t value, is going to be 1.5, 1.5 divided by 5.7. So the mass is going to be 200 times 0.5. And if I do 1.5 divided by 5.7, that gives me approximately 0.2632. Okay, so that means that my final mass, if I go through and I do 200 times 0.5 to the exponent 0.2635, it's going to equal 166.6 7 milligrams approximately. Okay, so you can tell that after an hour and a half, there's still a fair amount of caffeine in your body, and gradually, after 12 hours, that works its way all the way down to 45.5 milligrams. So one other thing that we want to change or take a look at here is if you went to Starbucks and you had an extra large express coffee containing 650 milligrams of caffeine at the beginning, how would that change your equation? Well, your original equation was the mass of caffeine starts off as 200 milligrams. Okay, but if you went and you got the extra large espresso coffee or whatever it happens to be, it would change your final amount, your equation, because you would end up changing the initial amount of caffeine that you had. So in this case, you end up with m is equal not to 200, but m is equal to 650 because your starting amount of caffeine is 650 grams. Again, doesn't change the half-life of caffeine. It just changes the initial amount. Okay? So there's another example of how you can use half-life along with your exponents in order to figure out the decay rate of certain things.